Oh, didn't see you guys there. Well, now that I did see you guys there, I'm going to tell you about solar panels. See, solar panels are a form of active solar power, a term that describes how solar panels make use of the sun's energy. Solar panels harvest sunlight and actively convert it into electricity. The solar cells, or photovoltaic cells, are arranged in a grid-like pattern on the surface of a solar panel. These solar voltaic cells collect sunlight during the daylight hours and convert it into electricity. See, solar panels are typically constructed from crystalline silicon and more expensive gallium arsenide, which is produced exclusively for use in photovoltaic cells. Newer solar panels are constructed at the molecular or even quantum level using nanotechnology. These do not require the silicon aspect of ordinary solar panels, thus are more lightweight. Plastic solar panels are currently being researched so that they may be built into everyday appliances to supply continuous solar power. Their only current downfall is that they are fairly inefficient at this time.
Where does solar energy come from? Solar energy originates from the sun in the form of thermonuclear explosions when hydrogen atoms fuse into helium atoms. The resulting radiation travels to Earth where the photovoltaic cells capture and convert it into electrical energy and store them in batteries for later use. The sun radiates more energy in an hour than has been used in the history of human civilization. Photovoltaic cells help us use this energy to meet our everyday needs.
How do solar panels work? As mentioned, solar panels capture solar radiation and convert it into electrical energy. They are comprised of several solar cells. These cells act as large semiconductors and utilize a large p-n junction diode, a crystal connected to two electrical terminals that conducts electric current in only one direction. The energy generated from photons striking these diodes allows electrons to be knocked out of their orbits and released. An electric field inside the solar cells pulls these electrons in a directional current, from which contact with metal then generates electricity. Increasing the number and quality of the solar cells increases the total output of the panel. This conversion of sunlight to electrical energy has been dubbed the photovoltaic effect. The amount of solar radiation that strikes a single location over a given period of time, usually one day, is called insolation. In order to maximize your solar panel's output, you want to have a higher insolation rating. Factors that can affect this are weather, latitude on the Earth's surface, obstructing objects that can create shade, and angle/position that the panels are installed. The latter of which can be improved by installing the panels on dynamic mounts that follow the sun through the sky and rotate the panel in order to get maximum insolation. We chose to do our topic on the technology, application, and implications of solar panels. Solar panels take advantage of the photoelectric effect in order to generate electrical energy. If a photon from the sun strikes the solar panel and an amount of energy greater than the work function of the electron is absorbed by the electron, it will cause the electron to become excited and possibly cause them to eject from the valence band to the conduction band of the atom, as calculated with this formula. W is equal to HFO. In order to take advantage of the photoelectric effect, a mechanism is installed in order to capture the ejected electrons by generating an electric field which causes the electrons to flow in a directional current towards the semiconductor. This semiconductor then collects the electrons from the conduction band as electricity. The electricity is then stored in rechargeable batteries for later use.
Environmental. Using solar power means decreasing the use of natural gas. This means the pollution made by a solar home will be greatly less than one of conventional heating. These systems also create energy without contributing to greenhouse gas emissions. This is an offset of approximately 6 tons of CO2 over the 20-year life of a solar system. Developing countries that are largely without power use dry cell batteries very commonly. The disposal of these batteries is a big issue. Using solar power reduces the amount of batteries that need to be disposed of.
Economical. At this time, solar power is not a cost-effective solution for household electricity needs. The cost for a solar system is far more than the cost for grid power over the lifespan of a system. As technology improves, the cost will continue to go down, but the only way to get the technology at a lower cost is to have a mass amount bought at one time. This mass number is hard to reach until the price is lowered, so it's a catch-22. If solar power ever becomes the standard, the price of solar systems will have decreased considerably. At that point, we will no longer rely on fossil fuels for our electricity.
Legal. Currently, the United States has an incentive program which differs from state to state, offering tax breaks, rebates, or other help for people to purchase solar power systems. In Canada, there is already progress being made toward a system of similar design, awarding people for being conscious of the environment. In Britain, there is an act passed in 1959 protecting the citizens' right to light. This wasn't originally intended for use with solar energy, but has now contributed to people having the right to use any light on their property to make solar energy with.
This idea can change the world.
Coming to a home near you.
That's aluminum foil. No, man. It's a solar.
This summer.
But when a photon from the sun comes down and hits this panel with just the right amount of energy, an electric charge is produced. And that can power the world.
The search for power is over.
This is madness! Madness? This is the photoelectric effect!
One sun to power it all.
How much does it cost? Well, for a system that creates 3.6 kilowatts, near like $32,000 or so. That's unreasonable.
One panel to guide it.
But it'll eventually pay for itself.
Okay, so to run the numbers. So it costs 38 cents per kilowatt hour compared to 4 cents for oil. That's just not efficient.
Yet.
This June 22nd.
I think I've got it. Yes, it's perfect.
They'll never see it coming.
Mr. Sack, you get yourself a deal.
This is genius.
Oh no! Blast, James!